Welcome back. Now that we know the columns that are required in our goal tables and where to get the source data from, let's start writing a select statement which will give us the required output. Well, then turn that into a stored procedure so that we can satisfy some of the non-functional requirements, such as being able to process the data for a new month without recalculating all of the data. Let's switch over to Synapse Studio and start writing the select statement. Here we are in the Synapse Studio. As you can see, I've created a new script and call that as create gold trip data green. The gold represents that the table is going to be created in the gold layer or the gold schema, and we are going to have the trip data information in it. So we're going to write this select statement here. And as we said previously, we are going to turn that select statement into a stored procedure. And at the end we'll be calling this stored procedure from this script. But let's start with this select statement. In order to write the select statement, we need to identify the tables from which we are going to get the data from the talked about for different tables, which are type data, calendar payment type, and taxi zone. For the trip data, as you know, we've got a view and the view has got the partitioned columns exposed as well. So it's better to use that view so that we can prune the partition. So that's what we're going to use. So I'm going to use silver.toView. And I'm going to alias the table as well because we're going to have many tables being joined here. I want to be able to reference columns from each of the tables with the alias quickly rather than giving the full table name. So we're going to alias that is TD for trip data, and let's put the columns we need. So on this view, we've got the year and the month that we need, as we said previously. And also we're going to get another column called to date that isn't a column called trip date, but we have got the pickup date and the drop-off date. For the purposes of this work, let's assume that pickup date represents the trip date. As you can imagine, a trip can start from one day and go over midnight into the next day. But for here, we are going to take the pickup date from when the client was picked up or the customer was picked up, and that's what we're going to call that as trip date. Having said that, in this column, we've got the date and the time component, but for our purposes, we don't want to have the time component. We were going to aggregate all of the data into a date level so that we've got a few records in our aggregated table. And also we can join that data to our calendar to get the day of the week and things like that. So we need to do a convert for that. So let's start with the year and the month, and then I'll tell you the convert function for the trip date. So in order to convert the date time into date, we can use the convert function. And for that you pass in the first parameter as date. And also we need to now provide the column name. So we're going to use the column name td.pickupDateTime, and we're going to alias this trip date, and that's everything we need. But I'm going to do a where clause to restrict the data being selected with the year as 2020 and month as 01. This is not only to restrict the amount of data we're selecting now, but also we have a requirement to be able to process each month separately as part of a non-functional requirement. So we'll do the where clause, have hard-coded it now, but when we turn it into a stored procedure, we'll use parameters to pass the values. I'm also going to restrict the data being selected before I run it to the top 100 records because we know that we've got about 500,000 for each of the months. So let me run this through, and we've got the data as we expected. We got the year and the month, and that took it. If you look closely, that is missing the time component. It's only got the date, and that's what we wanted. So let's move on to the next join. We need to join to our taxi zone in order to get the borough. So let's join this table to the taxi zone table. We can pick the taxi zone from our silver layer for this one. We don't have a view. We've got the table itself. So let's use the table itself. And I'm going to alias as TZ for taxi zone, and let's give the condition on which we need to join the data. So let's use t.d. We've got a number of columns, but we want to use the location ID for the pickup location using the pickup date time as the trip date. So we may as well use the pickup location ID to join taxis on taxi zones. Got the location ID column as well. So from this table we want to select the borough. So I'm going to put the borough here. So let me run this through. I quite like to build on my select statement to say and test it as I go along so that if there are any little issues we can find out there and then. So as you can see again, the data list looks as we expected. We got the borough as Queens for these records. So let's now join to our next table. So we want to be joined to our calendar so that we can get the day of the week for the trip. So I'm going to join the calendar table and I'm going to alias this as cal here. The join is going to be slightly tricky on the calendar table. We've got a column called date to which we are going to join a trip date. Because our pickup date time has got a time element. We won't be able to use that. We like to use the bait with the convert function. So let me do that. With that, we've joined the calendar table to trip data, but we need to pull out the day of the week. So the calendar table has got a column called day name, which will have the name of the day, which will be like Monday, Tuesday, etc., and I'm going to alias that as trip day. We also had one other requirement, which is to find out whether the day is a weekend or a weekday. So in order to do that, we can use the case statement to find out whether it's Saturday, a Sunday. If it is Saturday or Sunday, we will mark that as a weekend. Otherwise, it'll be a weekday. Let me do that. So what I have done here is have a case statement which is checking to see whether the day name is in Saturday or Sunday. If that's the case, it's going to mark the values Y. Otherwise, as in. So if it's a weekend, you're going to have a Y. Otherwise, it's going to be N. And so that's everything we wanted from the calendar table. So let's run this through. So I've got an error saying ambiguous column name is because we've got the year in both trip data as well as the calendar table. I like to just use the alias, so that'll be the year, and I'm going to put the same on month as well, just so I can avoid any errors in the future. Let's use it in the where clause as well. And now we've got the output. As you can see, the output has got the year, month, borough, trip date, trip day. So now you've got the Sunday, Wednesday, Friday, everything. And also, if it's a weekend, you've got the flag being set to Y, otherwise it's being set to N. Now let's join to the final table, which is our payment type table. So here again, we are going to use the payment type from a silver layer, and I'm going to alias that as PT, and on the end last year both tables have got the payment type, so it'll be td.paymentType equals PT payment type. So from this table, what we want is to find out the type of the payment, whether it's a credit card payment or a cash transaction. And then we want to get the number of trips being made. So in order to do that, you need to use an aggregate function which will be sum, and then you want to check whether the payment was made using credit card or cash. So let's start with the credit card transaction. So what I have done is I've done a sum, and also I'm checking whether it's a credit card transaction. If it's a credit card transaction, I give a value as 1. Otherwise it's a 0. So every credit card transaction is going to have the value 1, and then the sum will add all of them up and you end up having the card that counts. So I need to comma here, and also I'm going to copy this sum and just change credit card to cash. So this column is going to give you the cash trip account because we are using the aggregate function. We want to have the group by expression. So I'm going to just add the group by with the rest of the columns. So we want all of these columns. I'm just going to put them in there. So with that, we've achieved everything we wanted to do. We joined the trip data to taxi zone calendar and payment type. And we pulled out all the columns we need, and we have done aggregation as well. So in this case, because the aggregation is based on the year, month, borough, and the trip date, we are only going to have a few records. We're not going to have all of the data. So the data related to each of the trip dates in the borough are going to be aggregated. So we will see hundreds of records rather than the millions of records we were going to see. So I'm going to just remove the top 100. So it will give me back all that data, and I'm going to just run this through. So we've got our output here. And as you can see here, we've got the year, month, and the borough. And then, as we said, trip date and the day of the week, and we've got the indicator to say whether it's a weekday or a weekend. And you've got the trip count based on whether it's a cash or a car transaction as well for each of the day and each of the boroughs. We seeing the Bronx borough here. But if you scroll down, you're going to see the orders as well to Brooklyn, and you're going to see Manhattan and everything. So that is only about hundreds of records setting. So we got 193 records. So we've done the aggregation. So this table is going to be small ones. We don't know the aggregations. And when reports access this data, they're going to be really quick. We're also going to partition the data in our gold layer using the year and month as partition columns as well. So they have the ability to prune the partitions as well. So now that we've got the select statement, we can use this select as part of the CDAS statement to be able to create the external table with this data. We'll do that as part of building the stored procedure in the next session.